Potentiometric titrations involve measuring the voltage or potential difference between a reference electrode and a working electrode during a titration. The endpoint of a potentiometric titration is the point at which the analyte has been completely reacted with the titrant. Several methods are used to determine endpoints in potentiometric titrations. 1. Inflection point method. This method involves plotting the titration curve, which is a graph of the potential difference versus the volume of titrant added. The endpoint corresponds to the inflection point of the curve, where the slope is steepest. 2. First derivative method. The first derivative of the titration curve is calculated, and the endpoint is determined by locating the maximum or minimum point on the derivative curve. This method is particularly useful when the inflection point is not well defined. 2. Second derivative method. Similar to the first derivative method, the second derivative provides a sharper peak at the endpoint. The endpoint is determined by locating the maximum or minimum point on the second derivative curve. 4. Grand method. The grand method involves plotting the logarithm of the electrode potential against the logarithm of the volume of titrant added. The endpoint corresponds to the point of maximum slope on the resulting straightline portion of the curve. 5. Half neutralization method. This method involves titrating to the point where half of the analyte has reacted with the titrant. At this point, the slope of the titration curve is steepest. The volume of titrant at the half neutralization point is then used to calculate the equivalence point. 6. Zero slope method. In this method, the endpoint is determined by locating the point on the titration curve where the slope is nearly zero. This can be done visually by drawing a tangent line and finding where it intersects this axis. 7. Statistical methods. Statistical methods involve analyzing data points to detect a significant change in potential. This can include techniques such as the statistical evaluation of repeated potential measurements or the use of statistical software to analyze the titration data. 8. Visual indicators. In some cases, visual indicators can be used to signal the endpoint. These indicators can be added to the solution and cause a visible change, such as a color change, precisely at the endpoint. However, visual indicators may not be suitable for all titrations. 9. Potentiometric pH sensors. P-sensitive electrodes can be used as potentiometric sensors to determine the endpoint in acid-base titrations. The electrode potential is related to the pH of the solution, and the endpoint is reached when there is a sudden change in pH.